notes for you. So if you were gone yesterday, or you just or you couldn't get things written down fast enough, or you missed anything, or if you're gone today and I can't hear me right now, this is still for you. So in today's activity, I have the unit notes. They're also on our notes page, so you can go find them. I posted the first parts of this, the first and second parts of this, along with assignments like last week and 2 weeks ago. But the unit notes from for the whole unit are here. I went through and filled all of them out yesterday, and I also like went in and I typed in a summary. So if you want a summary, you got one. But what I think is better is that if you use the notes from yesterday, I think it's better that you go through and read the notes and you write your own summary first. And then you see how my summary compares to yours. I think you're going to learn more that way, and probably going to score better on my test if you do that. But either way, I got your back. So if you don't want to do that, I guess I don't really care. You have your summary right here. And then I have filled in, I did all of the activities that I was going to ask you guys to do. I canceled 0 pairs where we needed to cancel 0 pairs. And oh, this part got a little bit messed up, so I'm going to go back and fix part of this, and you might want to fix that part too. But I filled out the part about keep, change, change. I summarized it, and then we talked about expressions with parentheses. We're going to talk about all of those today. And I want to let you know that if you missed something, this is here for your review, and you can use it however you want. And you can save it the way we did yesterday and write on it all you want. Doesn't matter. It's for you to mess with. Does anybody have any questions about that part? Okay. Well, I believe we left off. Didn't we leave off like right in here somewhere, right? Did we cover this part already yesterday?
Yeah, like where the equations were, we told us to do them.
I told you to do these ones?
Yeah, that's what it saved for me.
Okay, and then the summary, but we didn't get to making 0 pairs? Or did we?
Wait, no, we were there.
We did make it to making 0 pairs. Okay.
Yeah.
So this part's all filled out again for you, so that's cool. I would prefer if we made it all the way to making 0 pairs. I want to know if anybody has any questions about making 0 pairs, and then I'm gonna show you guys the next section, which I think is really important. The next section is like the most, I think the most crucial parts in terms of like algebra tiles and simplifying. No questions about this part. All right, I'm gonna change my share, and I'm gonna put you guys on my put my iPad on your screen. Ooh, my back hurts, boy. Okay.
My gosh, same.
I know, it's not good sitting here doing all this stuff. So after we talk about after we talk about 0 pairs, right? 0 pairs are when you have opposite amounts on the same side of the line, right? If you add a negative to a positive, they cancel out. And if a negative on a positive, if you subtract a negative and then also subtract a positive, that's going to cancel out too. And if you, but if you also, when you add and subtract the same amount, like this makes sense, right? If you have 7, if I add 7 and then I subtract 7, I'm right back where I started. If I add -2 and then I subtract -2, I'm right back where I started. So it makes sense that if you have the same amount being added and then also subtracted at the same time, it's like nothing really changed. We see that here. I'm going to let you guys go ahead and fix all these 0 pairs, but it is important to remember that the variables work the same as regular numbers. So if we already know that 2 plus 4 is 6, then 2x plus 4x is 6x. Like the way that diagram works here, 2 and 4 on this, 6 is the total, then 2x's and 4x's on this, 6x's is the total. Oh boy, it's coming down out there. And sunny. I bet there's a great rainbow outside right now. And then there's 7 minus 4. It works like right? The way that works is the way you would diagram that is 7 on the top, adding 7 and then subtracting positive 4. And then the 4 on the top cancels, or on the bottom, cancels out 4 on the top. And then what's left are those 3 that aren't circled over there. And that is my answer. See, the 3 is this 3 that's like not canceled out. So just to review that for you guys, I wanted to do that before we talked about something called keep, change, change. Now, keep, change, change. I'm actually gonna delete some things here before we go over this. Keep, change, change. What we're doing is we're looking at 2 different things. We already know, if I go back to keep, change, change is the up house. Remember we talked about the up house and the 2 different ways to make the house go up? What were the ways to make the house go up?
Adding balloons.
Adding balloons, and what else?
Taking stuff out.
Taking away weight, right? So that's what this is, right? So over here, this is adding balloons. I have 2, the house is being held up by 2 balloons. If I add 4 balloons to it, it's gonna make it go up. If I add, here, I need to delete this part though. Same Z's, if I have 2 balloons pulling the house up and then I subtract 4 weights from the house, that's also gonna make the house go up. Both of these do the same thing. And so it says these maths are equivalent. That means, so what in their differences are equal? So some of my letters got messed up here, so I'm gonna go fix those really quick. And then I also, so the difference is the different tiles have crossed the line and changed the sign. So when I look at this, the only difference between this side over here, this is a house that's being picked up by 2 balloons and then I've added 4 weights to it. That's the same as a house being picked up by 2 balloons and then 4 balloons are taken away from it. It's a little bit harder to conceptualize, I think, but it's still the same. It means that like, this is going down. So the only difference here is that we look at these and I see that these 4 tiles here, they have crossed the line to become these 4 tiles, but they haven't just crossed the line. If I just have them go across the line, that doesn't change, that changes my value. That adding 2 and subtracting 2 are different things. Adding -4 and subtracting -4 are different things. So it's not enough just to have them cross the line. They also need to change their sign. So they also need to become positive once they cross the line. So adding the negative is the same as subtracting the positive. And vice versa, if I started with these negatives and I wanted to, the positives that are being subtracted, I could move them up here and say I was adding a negative, and that's the same thing. So these are the same. Does that make sense? Y'all follow me on that?
Yes.
Yes.
Any questions
Yes.
about that? So it also works the same down here. If I take my tiles and I have them cross the line and flip over, so they have to also flip to negative or to positive. Notice that this looks exactly like this over here. It's because they're the same thing. And if I take these ones and I drop them down and I make them negative, then it will look like what this side over here looked like before I drew the altered tiles, right? So they go back and forth. They're the same thing.
Yes.
So that's a really important thing to understand. Here's my summary of that. This is called keep, change, change. And we call it that because you keep the sign of the first number, but you change this and you change this. So you change the operation, change the sign of the second number, and make them look like that. And it
The
gives
one
you
that
this,
I have doesn't have a summary thing.
and it gives you the same value. The last thing I want to talk about is expressions with parentheses. Now, this is something that a lot of people got wrong that understood everything else. So I want to make sure that you're following along with this. But the way this works is, let's see. The way this works is that It says amounts in parentheses go as they are drawn on the side before, on the side of the sign before the parentheses. So what that means is when I have something in parentheses, I need to erase this. When I have something in parentheses like this, 2x plus 2x plus 1, then all of this needs to be like built just like this. So here is 2x plus 1. This is all going together. And because it says we're subtracting 2x plus 1, it means we're subtracting 2x and we're also subtracting 1. So those are going to go down here and be that. Does that make sense? So the
Yes.
3, so the 3x is here. The 4 is here. And then the 2x plus 1 is that. So when I diagram this, it's going to look like that. And then once I'm done, I can say, oh, I see 0 pairs, 0 pair, 0 pair, 0 pair, right? I can say 0 pair and go, what's left? I have 1x and 3. That's how I can simplify this. Same thing here. I have minus -6 plus 4x. So there's my -6. There's my 4x. It's on the minus side, so I'm going to pop it right there. And then I have plus 5, and that's going to go there. There are no 0 pairs to cancel out here. So this is as simple as I can make it. So this last one, if you downloaded the completed version, I've already completed it for you. But if you didn't, I said, now you try. And I asked you to draw these things. You had a blank table down here. So you can do that on your own. I think it'll be a good exercise for you. But the point is that whether it's like if it's on the positive side, it goes up here. If it's on the negative side, it goes down there. And it's just exactly what you see in the parentheses. It's exactly what it is. Does anybody have any questions about that? And does anybody feel so confused about it they don't even know what to ask?